Good morning. In this video, we are going to see double block problem. There will be two masses given and one mass will be placed over the another. One block will be positioned over the another. So it is a type of problem. Now let us go to the problem now. Find the force required to pull block B as shown in the figure. The mass of A equal to 40 kg and B equal to 60 kg. Coefficient of friction between A and B is 0.3 and between B and the floor is 0.25. So this is the given diagram. Here is the block B which is located on a floor and the mass A is located over the block B. Then this A is connected to the wall with the help of a string or a rope and which is inclined at the angle of 30 degree. Okay, so this is the given condition. They have given the friction between A and B as 0.3 and between B and the floor as 0.25. Now they were asked as to find the value of this P to move the block B. So this is the given problem. First convert this weight mass into weight by multiplying 9.81 and here 40 is nothing but mass of the block A. By multiplying 9.81 you will get the weight W1. Similarly weight 2, okay, weight of this block, just multiplying 9.81 you will get the answer. Now in this problem we have to make an important decision. There are two masses A and B. Now we have to decide which mass to be taken first and to be analyzed. Okay, there are two blocks, we have to decide now. For that we have to go for again free body diagram. Now this is the free body diagram of the block A. There are four forces: weight, N, F1 and tension. There are four forces and among these four, this is the only known force. So there are three unknown forces. So this is the free body diagram of the block B. There are six forces and among these six forces the only known force is the W2. Okay, and now you just compare these two. This is the free body diagram of A, this is the free body diagram of B, and choose the one which has less number of unknowns. Here the number of unknowns are 5, I'm sorry 3, and here the number of unknowns are 5. Okay, so you have to choose the block A to be analyzed first. Okay, so this is the important decision you have to make. Now let us go to the block A and now apply the equilibrium equation. Consider this as a particle. So you will have two equations. First one is summation of all vertical forces 0, summation of all horizontal forces equal to 0. Now use the first equation. Before that, go to the free body diagram. Now if you see here, there are three vertical forces. One is N1 and another one is W1 and the another one is T sine 30 degree. And among these three, these two forces are having positive sign because it is going towards the positive side of Y, and W1 is having negative sign. Now this equation became like N1 plus T sine 30 minus W1 which is equal to 0, and from this one you can get the answer for N1. Now let us apply the second equilibrium equation, summation of x equal to 0. Again go back to the free body diagram. Now this is the free body diagram of the block A. There are two horizontal forces. One is F1 and another one is T cos 30. Between these two, this is positive and this is negative. Now this equation will become like T cos 30 minus F1 equal to 0, and F1 can be written as T cos 30. Let us take this one as the equation number 1. But we know that the basic friction equation as F1 can be written like mu into N1, where mu is nothing but coefficient of friction. Now in the place of N1 you just substitute this value W1 minus T sine 30. So this equation now will become something like this. Now you see here in the first equation, in the left hand side you have F1. Now in the place of this F1 you just substitute this term. Okay, so now the equation 1 became something like this. But in this equation I want T only. Okay, so I'm going to bring all the terms related to T in the left hand side, and I'm going to take this in the right hand side. take the t out, and then t equal to mu w1 divided by in a bracket you will have cos 30 degree plus mu sin 30 degree. Now substitute all the values. You know mu value which is given as 0.3 w1. Again you know that it is 392.4 Newton. Okay, substitute everything, you will get finally 115.86 Newton. Now using equation 1, you can get the answer for the friction, which is nothing but 100.34 Newton, and the corresponding reaction N1 equal to 334.9 Newton. Now consider the second case, block B. Now let us go and draw the free body diagram for this one. So here is the block B. Okay. Now there should be a weight for this block, which is nothing but W2. Then there is a relationship between these two blocks at this point. So there will be a reaction by the block A to the block B. That's nothing but N1. So there are two forces at this area. Then you'll have a applied force over here. So there should be a friction force, okay, which will be just opposite to this P. Now you know that there is also a coefficient of friction between these two surfaces. So if you want to move this block in this direction, this surface will give some friction force that will act in the opposite direction only. So here also you have two friction forces. More than that, you will have a normal reaction, so which is nothing but N2. Like this, there are six forces are acting at the block B. So this is what here it is represented. Okay, this representation is very very important. You should know how these six forces are coming from. Very important thing. Now let us go and apply the equilibrium equation. The first equilibrium equation is summation of all vertical forces 0. Let us go and check in the free body diagram now. So this is the free body diagram. Now let us count how many vertical forces are here. W2 and N1, then N2. Okay. Now among these three, these two forces are vertically downward, so it is having negative sign, and this is the only force having positive sign. Now this equation became like N2 minus W2 plus N1 equal to 0. From this one we can get the answer for N2 as W2 plus N1. Now apply the second equilibrium equation, summation of x equal to 0. Let us go to the free body diagram again. So here there are three forces, P, which is having negative sign, F2 and F1. These two forces are having positive sign. So the equation becomes like F1 plus F2 minus P equal to 0. From this, P can be written as F1 plus F2. Let me take this one as equation number 1. We know that the basic friction equation is F2 equal to mu into N2. Okay, mu is nothing but coefficient of friction. Now N2 is here W2 plus N1. Now this equation became like mu into N1 plus W2. And now we know the value of mu, which is nothing but 0.25, and N1 is 334.9, and W2 is again 588.6. Now substitute the values, we'll get the answer for F2. Already we know the value of F1, which is 100.34 Newton, and substitute into the equation 1, you will get the answer for P, which is nothing but 331.215 Newton, and the corresponding value of N2 is again 923.5 Newton. So at the summary of this problem, the first thing is that understand the given problem well. Then identify and isolate the problematic area. That is nothing but drawing the free body diagram, which is the second step, very important step. Do it very carefully. Then third one is applying appropriate equation. Then fourth one is solve the problem with very carefulness. Many calculation mistake will come, so do it very carefully. Then at last you just validate the answer. Okay, here we got the answer for P as 331.215 Newton, and here the given weight is 588.6 Newton. So almost the answer is correct. Okay, so in this way you have to validate your answer. Suppose your answer is too long, like in terms of thousand or lakhs, then there will be some mistakes. You have to identify where it is. So these are the things to be noted when you solve the engineering mechanics problem. Thank you.